Today we're going to take a look at adding and subtracting fractions that have monic denominators, and that means a denominator that has a single term. We're going to start off by just performing some quick warm-up math that we've been working on since elementary school, so it should be a very quick review on how to add pairs of fractions. Now, the way we can add pairs of fractions is we can combine them into a single fraction with a shared denominator and a sum in the numerator, assuming they have the exact same denominator. So our first example has two fractions with a denominator that's the same. It's 3. Because it's the same, we can add up the numerators in the top. We can share the denominator. So this is 5 plus 2 all divided by 3, which is 7 divided by 3. When we're working with problems like this, we're going to leave the answers as improper fractions. That's much easier when you're at this level of math than working with a mixed number. Next, we're going to take a look, okay, how can we approach this problem if we don't have a common denominator here? Well, we can find what we call the lowest common denominator. So we can list off multiples of our current denominators. So our current denominators are 2 and 6. And we can list off multiples until we find a number that these two, that falls into each category. So 6, 12, 18, those are my multiples of 6, and then 2, 4, 6, and all of a sudden I see a number that's shared between our two columns. It's 6, so our lowest common denominator is 6. Now, if my lowest common denominator is 6, then I need to adjust these two fractions so that both of them share the same denominator. In order to do that, I need to work with 1 over 2. This one does not have the denominator 6 like the other one does. So how can I do that? Well, I can multiply the bottom of it, the denominator, by 3. 2 times 3 is 6. That's what I need to do. If I'm doing that, I need to multiply the top by it as well, because this is, in a way, just multiplying the entire fraction by 3 over 3, which is a fancy version of multiplying it by 1. So this leaves us with 3 over 6 plus 1 over 6. Since my denominators are the same here, I can do what I did in the first problem, where I add up the numerators and share the denominator. So this is equals 3 plus 1 over 6, which equals 4 over 6. Now I can simplify that a little bit further. I can divide both my numerator and my denominator by 2, bringing me 2 over 3. And I didn't plan overly well enough here, so let's try and split this up. Perfect. Which equals 2 over 3. Now, the lesson to take away here that we can't forget from elementary school mathematics is that we must have a common denominator if we are subtracting or adding, to add or subtract our fractions. Now, how can we find common denominators if we're given a more advanced problem? Well, we might need to factor in order to solve it. We'll see how that goes. In terms of factoring, we shouldn't need to do too much other than simplifying today, but when the problems get a little bit more tricky, when we're no longer working with monic denominators, then we'll need to factor in order to work out what's going on in the bottom of our fractions. So if we take a look at the following pairs of fractions, I'll call them A, B, C, and D. Then we're going to try and find the lowest common denominators of each of these pairs. We're going to use the following rules that we see down here. So in terms of the coefficient, we're going to work with the coefficients the same way we worked with our problems up above, wherein we try and find the lowest common multiple of these numbers to work on in our denominator. In terms of the variables, we're going to take any variables that are included in the problem, and we're going to work with the highest exponents on these variables. So that means if I'm looking at example A here, we already have common denominators. Our denominators is the same, so our lowest common denominator, that's LCD, equals 3x here. And I'd rather switch to a red pen for this. Next, and we note the similarities between these two problems and our warm-up problems. These two problems, the only difference is we have an additional x factor in our denominators, right? We began with 3 and 3 as our denominators, and then we moved on to 3x and 3x. And then we went to 2 and 6 in our denominators. Here we're going into 2x and 6x. And so we're working with the variable x, the highest exponent in the denominator. In this case, it's just a hidden exponent, 1. So I know I need that x in my lowest common denominator. I also need a coefficient. The coefficient I already did the work for up here. The coefficient is 6, so my lowest common denominator is 6x. And again, I can accomplish this by multiplying the numerator over here by 3. If I do that, I need to multiply the denominator by 3 as well, and that might look a little bit better on the outside. So I multiply the 3, multiply the 3. In terms of question C here, okay, all of a sudden we no longer have coefficients involved, we just have variables. Because we have variables with different exponents, we need to take the one that has the exponent that's higher. So here, my lowest common denominator equals x squared. And finally, over here, then this is a combination problem. We need to A, choose the variable with the highest exponent, and B, we need to find the lowest common multiple involved from the coefficients, which in this case are 6 and 4. So let's try and list off their multiples. For 4, that's 4, 8, 12, 16, and we'll see if that's enough. For 6, that's 6, 12, there we go. That's our coefficient that we're going to work with. So my lowest common denominator in this case would be 12x cubed. We need to choose that cubed from the second part of the problem, from the second fraction involved. Now we could add those up. We're not going to do that quite yet. You know what? I might add up this last one here because it's more complicated, so we can just work our way through it first. So if my lowest common denominator is 12x cubed, that means I need to try and make sure each fraction has that denominator. In order to give my first fraction that denominator, I need to multiply the bottom by 3x. If I do that, I must also multiply the top by 3x. And on the other side, on the other fraction, I need to multiply the bottom by 2, meaning I need to multiply the numerator by 2 as well. So this would simplify into 3x squared divided by 12x cubed plus 6 divided by 12x cubed. Okay, now my fractions share the same denominator, so I can write them all in one fraction and add up the numerator. So that equals 3x squared plus 6 divided by 12x cubed. Okay, now all of a sudden I have a problem that I know how to work with. I have the skills to work with, but I haven't perhaps worked with it before. So here we're going to factor our numerator because I can do so. I can common factor my numerator, and then I'll see if I can cancel anything out. First I'll common factor, so that's a 3, leaving me with an x squared plus 2. And in my denominator, I'm left with 12x cubed. Okay, so I'm tempted to perform some cancellations, perform some divisions. Before I perform any cancellations, I must add some restrictions in here. I see a factor that's a variable in my denominator, so x cannot equal 0. Once I have that restriction out of the way, then I can perform any cancellations. In this case, it's actually only with the coefficients. I can divide 12 by 3, so I'm left with a 1 in my numerator, a 4 in my denominator. Nice and simple. The final product here is x squared plus 2. I no longer need to write that 1 because it would just be a coefficient of 1 divided by 4x cubed, and then I restate any restrictions that I have, so x cannot equal 0. This is how we can add our two fractions here. Now let's move forward. I'm not going to go into detail for A, B, or C, but you can do those as practice and see how they go. Let's move forward a little bit. We're going to first find a lowest common denominator, then we're going to simplify just like we just did. So my lowest common denominator here, I don't see any coefficients in my denominators, so I'm just working with variables. In this case, I have two different variables. I need to choose the highest exponent on each of the variables. So my lowest common denominator here would have the high exponent of 2 on the a, so a squared, and then the exponent 3 on the b, a squared b cubed. That's my lowest common denominator that I'm going to work with. Once I find that, I need to change each fraction so that they share that common denominator. So I need to multiply the first one by a, and if I multiply the numerator or the denominator by it, I also need to do the same to my numerator. And on the other side, b squared is the factor that I'm bringing in. So now I can simplify this. That's 2a divided by a squared b cubed plus 3b squared divided by a squared b cubed. I succeeded. My denominators are now the same. If my denominators are the same, again, I can add up the numerators and share a denominator. So my shared denominator is a squared b cubed. My numerator, 2a plus 3b squared. Perfect. Now, at this stage, before I'm finished, I need to make sure that that A, it's fully factored. In this case, it is. And B, I need to make sure I state any restrictions. So I have two different factors in my denominator, A and B. Both of them are lone factors, meaning they're single terms. And that makes sense because we're working with monic denominators here, meaning A cannot equal 0 and B cannot equal 0. We'll move forward a little bit. We'll take a look at the lowest common denominators down here when we're given different kinds of problems. We'll see how it goes. So 2a, I'm working with 2x over 5y minus a nice jumbled fraction. Here we need to find the lowest common denominator. That's the lowest common multiple between the coefficients. So my coefficients are 5 and 2. Well, 5 and 2, it's interesting because because obviously they can't divide into one another right here. I don't have a fraction as my third term here. If I'd like, in order to keep it nice and easy for us to view, I can think of that as 3 divided by 1, right? There it is as a fraction. I haven't changed the values involved. Now, I'm going to work with the multiples of my coefficients, so that's 5 and 2, and I'm just going to do it up here. So 5 and 2. Well, 5, 10, 15, and 20 are my multiples. 2, 4, 6, 8, 10. I see it right here. So it's a 10 that I'm working with. And then I need to find the variables involved in my denominator. So my lowest common denominator is 10. And then I see a y squared over here. Y squared. And I see a z as well in my denominator. Note, in this question, I have an x involved as well, but it's only in the numerator. Since it's only ever in the numerator, I never need to see it in my lowest common denominator. So I'm working with 10y squared. That's my lowest common denominator. Let's figure out what I need to multiply these fractions by in order to accomplish this. Well, first I need to multiply the denominator here by 2 times y times z. If I do that to the bottom, I need to do it to the top as well, 2yz. And then over here, it looks like I'm just missing a factor of 5, so we'll multiply that in. Again, both to the top and the bottom. And over here, I don't have any denominator. Well, my denominator is just 1 at this point, so I need to multiply it by my entire LCD there. 10y squared z. Bring that into my numerator as well. 10y squared z. Perfect. Now, once I've done this, I can start multiplying in. So my first fraction becomes 4xyz. My second fraction becomes 10y squared z, just like I need. That's my LCD, my lowest common denominator. Minus, I need to make sure that stays as a minus sign, minus 5x cubed divided by 10y squared z plus 30y squared z, all divided by 10y squared z. Okay, perfect. Now at this stage, I have 3 different fractions. They all share a common denominator, so I can write them in as one fraction. My numerator is 4xyz minus 5x cubed, and I'm just adding all the numerators together, not forgetting that subtraction sign, plus 30y squared z. All divided by 10y squared z. Now, nice and easily here, I can take a look. I can try and factor. We actually don't have any common factors to my numerator. It's none of the patterns that I'm used to seeing, so I need to leave that as is. Though I need to check on my denominator. It is fully factored again because I'm working with monic denominators. It is fully factored already, so I can find some restrictions from here. I see 2 factors in the numerator, 2 variable factors in the denominator, sorry. And that's y and z, so y cannot equal 0 and z cannot equal 0. Perfect. Now, these are the steps. First, we're finding a lowest common denominator, then we're setting it to all of our fractions, then we're writing it all as one fraction, we're factoring if we can, and we're making sure we state our restrictions. So we'll work over here on B. Our lowest common denominator, I see a 6xy and a 3x squared. I know that 6 and 3, from my coefficients, the lowest common multiple is 6. And then I see an x, the highest exponent on an x is a square, and I also see a y in my denominators at some point. So that's the lowest common denominator that I need to work with. In order to accomplish that, I need to multiply the first fraction by 2x, and that means I'm multiplying the numerator as well. Now, here I need to make sure I consider what was in the numerator of my fraction as in brackets, because I'm going to need to perform my distributive property to multiply this 2x into it. And on the other side, and that should just be a single x. Single x. On the other side, that's where I need my 2, where 2y is what I need to multiply in. Again, I need to consider my numerator, my initial numerator, to be in brackets. Multiplied by 2y. Perfect. Now that I see this here, I can try, and I'm just going to move it over a little bit. For my second line, let's distribute our numerators, so that leaves us with 3x squared minus 15xy, all divided by 6x squared y, plus 30xy. Again, I'm distributing my 2y, even though it's after the brackets, not before this time, minus 6y squared, all divided by here 6x squared y. Perfect. Now I see my denominators are common, meaning I can write it as one fraction. So that's 3x squared minus 15xy plus 30xy minus 6y squared, all divided by 6x squared y. Now, really, when I'm stating my restrictions, I can do that as soon as I have my denominators, how they're supposed to look. Meaning, once my denominators are fully factored, I can start stating my restrictions. If I wanted to, I could have stated it in this line above. So let's do that this time, just to show you the difference. So the two variables that show up in my denominator are x and y. Again, because they're monic denominators, we can just take them here. So x cannot equal 0, and y cannot equal 0. Perfect. Now moving forward, we're trying to simplify this a little bit further. I notice right away, once I've written this, I can collect some like terms in my numerator. I see a negative 15xy plus 30xy. So we can rewrite this as 3x squared plus 15xy minus 6y squared, all divided by 6x squared y. We're getting some nice practice here working in a downward fashion, which is also nice. Now I need to work on some cancellations, meaning I need to factor first. So if I can take a look at the factoring, I see a common factor in my numerator. That's how I'm going to work. Because my denominator is monic, because there's only one term in my denominator, it's already fully factored. So I can take out I can divide out a factor of 3, leaving me with x squared plus 5xy minus 2y squared, all divided by 6x squared y. I can try and factor this numerator. Turns out I can't factor it any further, but I can cancel it. I can reduce the coefficients that I'm working with. I see a 6 and a 3, so I can divide those, leaving me with 1 over 2. My final answer here, if I'm stating it, is x squared plus 5xy minus 2y squared, all divided by 2x squared y. And because I'm finished, I need to restate my restriction, where x cannot equal 0 and y cannot equal 0. So that's how you do it. We can take one more look. I'm just going to point out, actually, you know what? I'm going to leave this for you to practice. You'll try and, if you're trying to work on this, let me remind you, you'll need to work with BEDMAS, meaning your order of operations. So thank you for watching.